morning, class. Hey, your attendance is so low. What is happening? Good morning, class.
Good morning.
Okay, that's fair. Now, okay, now today we are going to learn about the halogens, and at the end of this lesson, I will expect that you should be able to locate the halogens on the periodic table, and you will also be able to write the electron configuration of halogens in the periodic table. Now, who can tell me where the halogens are located in the periodic table? Of course, I know you have learned about the chemical families group. You learned about group 1 elements, the alkali metals. You learned about the alkaline earth metals and the others. So now we are at halogens. Who can tell me where the halogens are located in the periodic table? Anyone? Yes, and now halogens are located in group 7 of the periodic table. And halogens are very reactive nonmetals and are found in group 7 of the periodic table. Now, the name halogens is derived from the Greek word halo, which means salt, and gen, which means producer. What do we mean here? We mean that halogens are salt producers. If you take example of sodium, when you react with chlorine, it forms sodium chloride, which is a salt. Are we together? So that basically shows us that halogens are salt producer, and also we have said they are very reactive nonmetals found in group 7 of the periodic table. Now I want us to look at the electron configuration of the halogens. Now first I would like to write for you the halogens. We have fluorine. Is everybody looking here?
Yeah.
We have fluorine. We have chlorine. We have bromine and iodine. But in your high school level, mostly you will be measuring on these two. Are we together? Now, the atomic numbers for these halogens: fluorine is atomic number 9, chlorine is atomic number 17, bromine is atomic number 35, and iodine is atomic number 53. Now, coming to the electron configuration, who can remember how the rules we used when writing electron configurations? Who remembers? We said the first energy level occupies a maximum of how many? Yes, thank you, Brandon. The first energy level holds a maximum of 2 electrons. What about the second energy level? Use?
It is occupied by 8 electrons.
Yes, the second energy level occupies a maximum of 8 electrons. Now, writing the electron configurations, let's write for fluorine and chlorine. For fluorine, hey, are you looking what I'm doing here? For fluorine, the electron configuration will be 2. Then we are remaining with 7. Now, I would like one of you to come and write the electron configuration for fluorine, which is atomic number 17. Anyone? Yes, Brandon, you can come. You can write here the electron configuration for fluorine. 14. This is the electron configuration of chlorine. Now, when you look here, you note that the valence electrons of halogens both are 7. Now, this means that all halogens have their valence electrons. They have 7 valence electrons. So, it means that this one, they require to gain 1 electron so that they can form a noble gas configuration. Are we together? Is everybody looking here? Now let us look at the atomic and ionic radius of the halogens. Now when you look here, can everybody look up here? Fluorine has atomic number 9, chlorine has atomic number 17, bromine 35, and this one 53. What is something that is notable here as you go down this group? Anything you are not seeing anything? You cannot even see that the atomic number is increasing. Now the atomic number increases down the group. Now that means that atomic and ionic radius of halogens increase from up to down the group altogether due to the increase of the electron shells. You can see that fluorine has only 2 occupied electron shells and chlorine has 3 occupied electron shells. So this means that when you move down the group, the number of electron shells increases. That's why the atomic radius increases. Now, when you compare atomic and ionic radius, you find that the ionic radius is usually larger than the atomic radius. Now, why is the ionic radius larger than the atomic radius? First of all, I've told you that the halogens form a stable electron configuration by gaining 1 electrons, meaning they form ions with a charge of -1. Now, when the halogens gain electrons, you find that there is a repulsive effect between the existing electrons and the incoming electrons. So this makes the size of the ion to be larger than the size of the atom. Are you concentrating?
Yes.
Okay. I've said that the ionic size, the ionic radius is larger than the atomic radius because of the repulsive effect between the incoming electrons and the existing electrons. Are we together? So that's all about the halogens, electron configuration, atomic and ionic radius. So in general, today we are discussing about halogens. We say that halogens are nonmetals, very reactive nonmetals found in which group of the periodic table? Which group? Group 7 of the periodic table. And we also looked at the electron configurations of fluorine and chlorine. We wrote them down here. We said that all halogens have 7 valence electrons. Valence electrons are the electrons occupying the outermost energy levels. We also looked at the atomic radius of the halogens. We said that the atomic radius increases down the group due to addition of occupied electron shells. Now we also looked at the ionic radius. We said that halogens form ions by gaining 1 electron. So they form an ion with a charge of -1. We also said that the ionic radius is larger than the atomic radius because, who can give me the reason why the ionic radius is larger than the atomic radius? Yes, and yes, that is very, very good. James, what did she say?
Say that the reason why ionic radius is
that means you are not concentrating. We said that the ionic radius is larger than the atomic radius due to the repulsive effect between the existing electrons and the incoming electrons. Remember I said halogens form ions by gaining one electron. Now, having known that, I think we have known the halogens, we have known their electron configuration and their atomic and ionic size. Now, on your assignment, you write this assignment down. Write this assignment down. You explain why the ionic radius is larger than the atomic radius in halogens. Have you noted the assignment? You write the reason why, or you explain why the ionic radius is larger than the atomic radius of halogens. I will mark your books in the next class. Make sure you do.